Last example. The table shows a person's billable fee Y in dollars in the year T, where T equals 1 corresponds to the year 2005. First, we have to find a polynomial model for the data, and then we have to use the model to estimate the fee in 2012. Well, we can't really count finite differences here because this is a real-world situation. So when you get to a real-world situation, not all data works out perfectly for you. So what we're going to do is we're going to type the data points into StatEdit, and then we're going to look at a graph of what those points look like. So I'm going to go back to StatEdit and type those points in, because if I can plot those points, I can look at the shape of the points and the direction that they're moving and decide which function will best fit the direction and the shape of the points. So I'm going to type in all of my numbers. And then here's how you get these points to show up in your graph. All of these instructions right here. So we just did StatEdit and put our x's in L1 and our y's in L2. Now we're going to press the buttons second, y equals, and you should see the menu stat plot. We're going to go to plot 1, and we're going to press enter, and instead of having it highlighted as off, I'm going to choose on. Now, in order to get, like if I go to press my graph now, I'm probably not going to see too many points because your standard window goes -10 to 10 and then -10 to 10. I can tell my calculator to zoom in specifically to the points that are on my stat edit column by going zoom and then going all the way down to number 9, zoom stat, because all of your points are in stat, so zoom stat will zoom to where those points are. And we get a graph that looks like this. Now, the 3 functions we've talked about so far are linear, quadratic, and cubic in Algebra 2. This is not linear. Those points do not follow a linear graph at all. They are not all even in a straight line. They're not in a parabola because a parabola would either decrease and then increase or increase and then decrease. And these points look like they increase and then decrease and then increase again. So we think that this function is probably going to be cubic because those points follow the shape of a graph that a cubic function could fit. Okay? So because we know it's going to be cubic, we're going to go back and do StatCalc, choose number 6, cubic regression. However, these steps over here will help us not only figure out the function that fits these data points, but these steps will help us graph the function that we think fits these data points on top of the data points that are already there. So, follow the steps. We're at step 4. Stat, go over to Calc, choose cubic regression. And normally I just tell you to enter all the way through these steps until you get to calculate, and it shows up on your home screen. Okay? You can do that, and then you could take that function and type it into y equals, but that's a really long function to type out, and those numbers don't look like they're going to make nice, pretty fractions. So the shorter way to do that is to have the calculator take this information and directly transfer it into y equals without us having to manually type it in. So we're going to go back here and press Stat, Calc, 6, and instead of entering all the way through this to calculate, you're going to press enter 1, 2, 3 times. That says store the regression equation. We're telling the calculator at this point that we want to store the regression equation in y equals so that when we graph it, we can see it. Here's what you have to do, and they're all written out here. I'm going to press vars, which is this button right below the gray arrows, right next to clear. I'm going to go over to yvars, that's my option. And from here, the highlighted choice is the one that we want. So I press enter once. I want it to go into y1, so I press enter twice. I press enter a third time. And now I press calculate. And it's still going to show up here like it did before, so you could write that down. But if you go to y equals, you'll see that the function has been typed in there for us without us having to do it. That would have been a lot for you to type in. As y'all say, that's too much. Okay? I press graph, And sure enough, the function that we found from that table fits those data points perfectly, so we know that it is the correct answer. So, to write that down, I'm going to have to go back and do cubic again. I'm going to round to the thousandths place here. Y equals 1.472 x cubed minus 11.726 x squared plus 25.373x plus 5. There's our function. The last thing this question asks us to do is to use the model to estimate the fee in 2012. Well, they told us that the year t equals 1 corresponds to 2005. So 2012 would be 2005, 2006, 2007, 2008, 2009, 2010, 2011, 2012. T equals 8. And since our function has already been typed into y equals for us, all we have to do is go to our table and go down to x equals 8, and that y value is my answer. Since it's money, we're going to round to the hundredths place, $211.29 per hour, because they said that's the billable fee. And that's it.